So this is the setup we tried last week. So we had a public subnet. We created a private subnet. We placed an instance inside the private subnet. First, we tried to connect from our desktop over to our public instance and try to SSH from there to the private instance. So that's the first session we did. The second session was more around how do we do it via the NAT. So we placed a NAT instance in the public subnet as well as a NAT gateway, and we connected from the private instance onto the internet via the NAT instance and the NAT gateway. So those are the things that we discussed last week. So this week, the topics that we're going to look at, first one is the VPC Flow Logs. The next one is VPC endpoints. And the third one is Bastion hosts. So let's look at Flow Logs. So Flow Logs are Amazon provided service. They provide an overall visibility on the network traffic. So for our simple network, where we have a single VPC, we have a public subnet, we have a private subnet. This is the setup. If we want to understand what's going on our network, what we have provided with the AWS is called VPC Logs. So VPC Logs provides an overview of what's happening at 3 levels. So we can associate or enable VPC log at a VPC level. So when we have done that, so let me use a, so I was talking about the VPC Flow Logs and what it provides. So basically VPC Flow Logs provides a high level visibility on the network traffic. It's an agentless login system, which means we do not have to install any additional client software on any of the components within the AWS where we're going to monitor any one of these items. All we have to do is just enable it at AWS level. So again, this can be configured at granular levels. So if we look at our simple network, so we have a single VPC, we have a public subnet, and within it we have instance. Very similar, we have a private instance and subnet. So the way we divided the traffic is that access to private subnet is restricted. Which can only go through the the public subnet. So that's how we designed our route table, access list, and security groups. If we want to, for example, monitor what's going on at a VPC level, then we can enable flow logs at the VPC level. So what it does is it monitors all network activity across all subnets and all instances within them within the whole VPC. So that's what VPC level VP Flow Logs monitoring would provide us. We can refine it to a subnet level as well as to an ENI level. So if we want to monitor a single instance, what we have to do is we have to enable a flow log at an ENI. I guess everybody knows what an ENI is. So ENI is the Elastic Network Interface. So that's the network interface that is associated with our instances. Let me show you. We got 2 instances, a public instance and a private instance. So if you want to see what is our ENI, so you have to select the instance. That's the network interface here. Network interface ID. So this is our ENI ID. Again, this is an ARN, so which is an Amazon resource name, a unique identity for Amazon resources, which can be referred in anywhere within AWS services or in our scripts and so on. So this is where the ENI is located. So in terms of granularity, we can enable VPC flow logs at a VPC level, subnet level, ENI level. Depending upon our requirement and architecture, we can enable accordingly. Another important fact is flow logs only capture the metadata. So it does not capture the actual traffic itself. Say, for example, we have an instance here, we are monitoring that instance, and somebody is, say, for example, transferring a file over to this instance through FTP. What flow log would capture is someone connected at so-and-so time, through this protocol and whether the connection was successful or not. That's pretty much what the VPC flow log is going to capture. If we want to understand more around what is the actual data itself that's transferred, for example, if you want to do a deep packet analysis, we need to use additional third-party tools, for example, Wireshark. So VPC Flow Log is more of a lightweight tool. It provides only the metadata. So this is a key thing to understand. Again, Flow Logs does not necessarily capture everything. So there are exceptions to it. For example, the DHCP traffic within the subnets and the VPC, it does not get captured. Same DNS traffic does not get captured. Likewise, any traffic that happens within the VPC or within the subnet, depending upon where you have enabled, not necessarily gets captured by the flow logs. Again, it depends on your network and your architecture, traffic, and other things, but it's not really a real time. So potentially anywhere between 5 to 10 minutes delay is expected when you have enabled login and the logs to appear. So the flow logs that you capture can be stored in a CloudWatch logs, or it can be stored on S3 bucket. So CloudWatch logs provides you a very quick way of capturing and doing a really high level analysis of what's going on within your network. Whereas if you capture them onto S3, or once you capture them onto CloudWatch and then export them to S3, then you can perform a much more detailed and granular processing using third-party tools, or even Kinesis or Elasticsearch. So the flow logs gets inherited by the subnets and ENIs under VPC. So what does it mean is, say for example, you have this VPC, you have 2 subnets, and you have 2 instances within these 2 subnets. You have only enabled VPC at flow logs at the VPC level. You did not have enabled anywhere here. Very similar to route table, where it automatically, anything under that subnet gets associated to the default route table. All instances and all resources within the VPC will automatically inherit the VPC logging capability from the VPC level enabling of flow logs. So that's something to be mindful of. When we create or enable flow logs, we have to create a log group and we need an IAM rule. So very similar to all AWS resources, we need an IAM rule that has the permission to access and store the CloudWatch logs on the CloudWatch.